Here are some seats on the front if you want. It's like school. Nobody wants.
Ready. Good morning. Thank you so much for the introduction. I'm very excited to be here today to talk to you about our experience at Texas Children's Hospital, Baylor College of Medicine. And we've just had 2 excellent lectures. And so I'm going to tell you our 10-year experience of how we've increased human milk use in our unit and used an all-human milk diet to improve the outcomes for our smallest babies. It doesn't want to click. There we go. I do have 2 disclosures. Proactive Bioscience does fund 2 studies that I am a part of at my hospital, as well as my center is a site for the U.S. randomized SMOF trial for preterm infants by Fresenius Kabi. And for those of you that aren't as familiar with Texas, we were talking last night and we Googled the population, so 28 million. Houston is the 4th, almost 3rd largest city in the United States. And it is a little hot there, so I'm enjoying this weather for sure. So to tell you about my hospital, Texas Children's Hospital, just to give you guys a background. So I took over the Director of Neonatal Nutrition leadership role about 4 years ago. And our program over the years, we're pretty rigorous with guidelines. We spend basically all year long looking at latest evidence, updating our nutrition guidelines. We also have guidelines for the unit. And the reason we hold on to these guidelines, we have 175 beds. And more than, 3/4 of these are very critically ill babies. We have 60 plus, I think we've grown, neonatologists. You can see the latest number, we have 500 neonatal nurses. And you can see we're a very multidisciplinary team. But it's really neat how, as a group, we may not agree on many things, but we agree on nutrition guidelines, which makes my job easier. So today I'm going to talk to you about the use of human milk for preterm infants and talk to you about our experience with a donor human milk-derived fortifier. So I think in nutrition in general, we want to give our most vulnerable infants, preterm infants, the best possible outcomes. And the problem is we want to improve growth and we want to feed their intestines so we don't have to give as much parenteral nutrition. But we want to avoid risk. We're worried about feeding too much. We worry about necrotizing enterocolitis and other diseases. And so how do you balance this? And so we're learning more and more about human milk. It's interesting. Every year that goes by, there's more data to remind us that human milk, breast milk from mothers, is made up of many different components. So not just nutrition. We know there's immune components, hormones, growth factors, cytokines. And here is an example of the non-nutritional components. And the list is even longer than this, but this is just one view. And so to draw your attention, just for example, to certain digestive enzymes. So the bile acid-stimulating lipases help the preterm infant digest milk fat. And we know that pasteurization of human milk, leading to donor milk, that this enzyme is markedly reduced. And so we need to think about this when we're feeding our infants. And I'm glad to hear that part of the guidelines that have come out is to help, support mothers in their expression of breast milk and how important that is. And so talking further for preterm infants, some of the benefits we found of mother's milk and what's in the literature. So it's basically every organ system is affected. So less sepsis, less retinopathy of prematurity, which we know leads to blindness, improved neurodevelopment, decrease intestinal disease or necrotizing enterocolitis, and so on. And so this is a common picture we use in the United States. I'm not sure how much it's used in talks over here, but breastfeeding rocks. And so in 2012, which is getting further and further away the more talks I give, but the American Academy of Pediatrics came out with a position paper on breastfeeding. They really carved out a section for preterm infants. And back in 2012 in the United States, This was kind of novel because they not only recommended mother's milk, but they recommended that we should supplement with pasteurized donor milk. And many NICUs in the country in 2012 were not using pasteurized donor milk. And I know some of the European guidelines have come out supporting donor milk as a supplement as well. And so we know that our mothers of these preterm babies are not supposed to deliver early. Their bodies aren't used to producing milk, and they face many challenges. And especially at my hospital, despite our best efforts, our mothers cannot provide, not all of them can provide milk for their babies. A lot of them have health problems, and they're just unable to produce. But we know that there are different factors, different ways to help support these moms. And so it's very interesting to me how over time we're learning more about how to feed our preterm infants and how to use human milk to optimize nutrition. This is just one example. This is a analyzer that we use for research that can actually tell us the macronutrient analysis of human milk. So I was talking to Dr. Fuchs yesterday about targeted fortification, and so there is a lot of research ongoing in this field. We know mother's milk and breast milk's best, but how do we optimize it? Because these babies born at 24 weeks, etc., don't get that transfer of nutrition from mom because they're born early. And then I'll talk to you about an exclusive human milk diet, and this is from one of the studies showing oral care with colostrum, which is something we've implemented at my hospital. And so I will refer to the donor human milk-derived fortifier as a lacto-engineered human milk fortifier. So this product was studied, 2007, 2009. We started using it in 2009. And essentially they take pasteurized donor milk and they concentrate it and make it for essentially a fortifier, the appropriate amount of protein, calcium, phosphorus, fat, etc. So it was an option. So back in 2012, at least in the United States, we had mother's milk. We were, I say 2012 for Texas Children's, it was 2009. But prior to 2009, we had mother's milk, and then we would add a bovine-derived fortifier if we had mother's milk. If we didn't have mother's milk, we'd give premature formula. And so the benefit of an exclusive human milk diet for us is that we were able to add in donor milk. So if we didn't have enough mom's milk, we would add donor milk, and then we would add this lacto-engineered fortifier. So we were able to provide an exclusive human milk diet. So I should put a timestamp up here, but I would say in 2019, so 10 years, times have changed. A lot of units in the U.S. are using donor human milk as a supplement to mother's milk. So I would say the comparative diet would be bovine fortifier with these milk base, and then we still have the human milk fortifier, lacto-engineered fortifier. And so one of the initial studies by Sullivan and others that came out in 2010 really caught the attention at my hospital. One, we had a rather high NEC rate of about 14% back in 2008, 2009. And we also were one of the participating sites in the randomized controlled trial, basically comparing an all-human milk diet to a bovine diet. And that study showed a 60% reduction in medical NEC and a 90% reduction in surgical NEC. And subsequent studies, which I'll go through, which are some that have done at Texas Children's, show less mortality, sepsis, retinopathy of prematurity, and bronchopulmonary dysplasia. So we've really seen what this diet has done in our population and how it's improved outcomes. And I hate to bring this picture, but I think all caregivers don't want to see a baby with an acute abdomen that has NEC. And the problem is I'm part of the NEC Society, which is a U.S.-based parent organization that now has brought together the scientific community so we can, from a basic science, clinical research perspective and a parent perspective, work to decrease this devastating disease. But despite all this research, we know it's multifactorial. So we know enteral feeds are a part of it, bacterial colonization, and exaggerated inflammatory response. So as I mentioned, our rates were quite high in 2009. And so some of the other studies that subsequently have been published about an all-human milk diet show that it doesn't just decrease NEC, you have less TPN days, And then if you combine some of the data, you do see this decreased mortality and morbidity. And this is just a figure depicting that. So this is from the Sullivan 2010 study. So this is the bovine group. They did 2 fortification strategies, and that's part of why I'm here today. One of the strategies presented was that you could fortify as early as 40 milliliters per kilogram per day, which I think for most units is very early. So one of the groups was fortified at 40, the other at 100 milliliters per kilogram per day. And so this was something new, even to us. And so over the last 10 years, this is just a selection of publications that's come from our center, but we've found not only that these babies can grow receiving this diet, but overall improved outcomes. We saw this diet working in front of our eyes, that babies were doing better, they were healthier, and so we sought to capture this in a study. And most recently, and I think we will hear more about this in the next 5 to 10 years, is the intestinal microbiome. So we examined this in a group of VLBW infants and found significant changes based on their diet. And so this is one of the studies I'll talk about first. We implemented the diet in 2009. I'll show you our feeding protocol in a minute. But one of the concerns at the time was that, we're concerned babies won't grow on donor milk. We're not sure about this new diet. Yeah, it improves outcomes, but how do these babies grow? And what we found is that for 104 infants that received this diet, they were less than 1,250 grams, and they were just the first 104 babies that came into our unit that qualified by weight. And so we compared weight. This is our group here. We used an exclusive human milk diet, and we fortified at 60 milliliters per kilogram per day. And we compared that to the initial Sullivan randomized study groups in 2010. And what we found is if you look at the growth of our study group, we had about 24 grams per kilo per day of weight gain compared to the human milk groups in the study as well as bovine. And we also saw an increase in length gain. And I think we know for nutrition, we don't just want weight gain, we want length gain as well, because that can serve as a marker for greater lean mass. And so what was really striking to us is that our TPN days were significantly lower. So due to concern about sepsis, central line infections, that's a very big deal in the U.S. for us, we try to get the central line out as soon as possible. So there's a big push in how we feed babies to safely increase feeds, fortify them, give them the nutrition enterally, and then get out the PICC line or the central line. And so as you can see here, our TPN days were on median about 13 compared to the other groups which were in the 20s. And we also got to full feeds sooner, around 18 days. And so the protocol that we still, this is a newer version of it than what was studied, but the advancement rate is the same. So we, for babies less than 1250, give 3 days of trophic feedings or minimal feeds at 20 mLs per kilo per day. We go to 40, and then at 60 is when we add the donor milk-derived fortifier. And we actually add the +6 versions. That gives it about 26 kcal per ounce, and I'll show you about that. But we've had a lot of success, and people say, well, how can you start with 26 calories? And how can you start at 60 mLs per kilo per day? Well, again, this is a product derived from donor milk. It's derived from breast milk. The osms are very low. And so honestly, the osms are pretty similar across all the different concentrations, so we feel comfortable adding it early. We're adding breast milk to breast milk. And so we continue to advance. In a perfect world, a premature infant in our unit would be on 26 calories per ounce. It's 160 mLs per kilo per day. But often we have to limit the fluid. One of our strategies is fluid limitation for lung disease. And so sometimes we have to increase the calories. But just to give you an example, so in the U.S. we have moved towards liquid fortifier. There's been a big push for this. So there are 2 companies that make a liquid fortifier, bovine. There's still one company making a powdered bovine fortifier. And then this is the donor human milk-derived fortifier. And what I wanted to point out here is that generally you're limited to 24 calories per ounce with the bovine options, unless you do something off-label. The donor human milk-derived fortifier allows you to go up to as high as 30 kcals per ounce if you need it. And so this gives you a lot more options, many options, when you're trying to limit fluid or help a sick baby. And so this is from an up-to-date chapter that I write, but just looking at some of the differences in protein, calcium, and phosphorus. But if you look here, this is an all-human milk diet, and it provides at 160 milliliters per kilogram per day about 130 kcals per kilo, and then 3.9 grams per kilo per day of protein. And then this is a bovine fortifier powder that we use. Some units still use in the U.S. versus a liquid at 24 calories per ounce. And so you can see similarities in protein, but compared to the liquid bovine fortifier, the protein is still pretty high. But just to give you guys an idea. And so the story continues. So we were excited after a year of implementing the diet. Our NEC rate went from 14% down to about 3%, and it stayed anywhere from 2 to 4%. We also, as the initial randomized study showed, we have very few cases of surgical necrotizing or coli, so less babies getting surgery. And then around this time, we were finding, or there was more attention being brought to, we know mother's milk is best, but it varies in calories. And some mothers may have high-calorie milk, some may have lower calorie. Obviously, we want to use it, but we might just need to think about that when we're looking at our fortification strategies and how we're providing nutrition. But what was striking in one of these studies is that 65% of the human milk that was sampled was less than 17 calories per ounce. So again, if you think you're adding an additional 4 calories per ounce of fortification, you're not necessarily meeting your goals. And so around this time, in addition to nutrient analysis with the milk analyzer, we were able, there was a new product available, human milk cream. It's basically donor milk fat. So when they pasteurize the donor milk, there's a skim component and a fat component. They essentially turn that fat component into a product of 2.5 kcals per ml. So it was a way to give additional fat from breast milk. And so we studied this, and the thought was if we could raise mother's milk to 20 calories per ounce, which what we think it should be, could we see better growth with these infants? And so going through, you can see we had a control group and an intervention group. And the intervention group, essentially, if the milk was less than 20 calories per ounce, we added a small amount of cream to increase it to 20. So it kind of looked like this. If mom's milk was 18 calories per ounce, we would add 4 mLs of human milk cream to get it to 20. And so what we found was that the babies that received the donor milk fat had better weight and length gain and similar head circumference. But this is very encouraging because I think we're afraid if we give more energy or more fat, we'll make our babies fat, basically. And we found that they also grew in length, which was reassuring. Another interesting point, which further brings out why we should think about the calories of mom's milk. We had 2 sites in the study, and I'm not sure why our Houston moms had higher calorie milk. I don't know if it's our population, etc., but the San Antonio, another city in Texas, had much lower on average mother's milk calories. And then we had no NAC in either group, and our sepsis rates were even and no deaths. And so our next part here, talking about, we saw these babies were doing better, so we wanted to look at additional outcomes. This is Liam. His mom gives me permission to share his pictures. He's now, I think, 7 years old. But just showing, I think we're all here to improve safety, and we want these babies to go from being tiny to growing up and being able to give us a thumbs up when they see us and follow up. And so this was a pre-post study. Basically, we looked at 1,500 plus infants. Pre was a bovine diet, post was a human milk diet. And what we found is what we've seen all along. There's a significant reduction in NAC and mortality. Just for sake of time, so I want to leave time for questions, we also saw everything else we had seen clinically, less sepsis, mortality. weight gain was similar. We had less ventilator days, less bronchopulmonary dysplasia or lung disease, less severe ROP, and less PDAs. And we also have looked at growth, because this is still a concern. Babies don't grow on donor milk. And we showed that indeed with an all-human milk diet, for this at least, their weight gain was similar, but their length was better in the all-human milk group. And so from this study, again, we found all these positive findings. And so just some considerations and things we've learned over the years, and it's shocking to me that we've been doing this for 10 years now, and I think I estimated we've probably treated over 3,300 babies. We have a very large unit of preterm babies, and so we've learned a lot along the way, but some considerations that we found is that it decreases morbidities and mortality associated with prematurity, provides an all-human milk diet, and this is becoming very popular in the U.S. because mothers don't want formula given to their babies, and they don't want unnatural substances given, and so it does provide an all-human milk diet. The other benefit I talked about is that you can concentrate your feeds. You can go as high as 30 kcals per ounce, or with the cream, you can go up to 34 kcals per ounce. It gives you options, so you don't have to use formula. It is expensive, but there are multiple studies that have come out, and one recently showing a cost savings. So if you can prevent one case of necrotizing enterocolitis, you can pay for the product. And so some people say, oh, you're at a big hospital, you're in the U.S., you can pay whatever for this product, but I actually have to talk to the hospital leadership every year, show them our outcomes, and I still literally have to fight for it. So it does take some effort. And then we do have long-term outcomes that I'll talk about tomorrow, but very promising long-term, not only body composition, but neurodevelopment. And then you can fortify early, which I know is a newer concept, and but studies have shown you can start as early as 40 mLs per kilo per day, and it is safe. Remember, the OSMs are quite low. So with that, these are 5-year-olds that I'm in the process of publishing their data, but just to show you, I'm 5'4", Matrix is standing on his name's Matrix, he's standing on a ledge here, but all these kids are very lean. They're not the shortest in their class, they're mid-height, and this is Ansley, she's a star soccer player. So we've just been very pleased, and I will entertain any questions.